So what is the derivative telling us about functions? It's telling us we don't need to look at tangent lines anymore. We can simply look at the graph to get an idea of the derivative and vice versa. So since the derivative is the slope of the tangent line, let's look at what's happening with this graph as we move the tangent lines. So my tangent line obviously has a positive slope. My derivative is going to be positive. As I move the point of tangency, the slope is decreasing. The derivative is decreasing. As I reach a turning point, notice what's happening. My tangent line has a horizontal slope. Has a slope of 0 because it's horizontal, and my derivative is 0. If I can get it right. I probably can't get it right there, but I'm sure you believe me. Now the slope of my line is negative, my derivative is negative. So the value of the derivative is the slope of the tangent line at that point. So I can see what the function's doing anywhere if I know the derivative, and I can plug in a value. So, for instance, I can quickly say that the derivative is positive where the function's increasing, because the function's increasing means its tangent line has a positive slope. And I can quickly say on what intervals is the function decreasing if I know where the derivative is less than 0, because that means the slopes of the tangent lines are negative, which means that the slopes are going down, which means that the function is decreasing. So here's an example from a homework problem. So sketch the graph of a function that's continuous on the domain -5, 5, and where you have these conditions. So you have g of 0 is 1. That's giving you that the point 0, 1 is on the graph. G prime of 0 is 1. So this is telling you that at 0, the slope of the graph is 1 in some interval around 0. G prime of -2 is 0. Is telling you the slope of the graph, or the slope of the tangent line to the graph at x equals -2 is 0. So that's telling us that the tangent line's horizontal. So we have a local maximum or minimum or turning point at x equals -2. The limit as x approaches -5 from the right is infinity. Tells us that at the left end point of the domain, you have a vertical asymptote going up from the right side of the asymptote. And this is telling us that on the right side of the domain, as x is approaching 5, the function has a horizontal asymptote at 3, y equals 3. So there are a lot of different possible graphs, but remember this would be something where you would need to actually draw the graph, not just choose a multiple choice graph from WebAssign in a test situation. So let's start off here. So 1, the slope of the graph at 1 is we're given as 1, right? G prime of 0 equals 1. So the slope of the graph at 0 is 1. So the first thing I would do is draw just a little line segment at the point 0, 1 that has a slope of 1. G prime of 0 equals 1 means the function has a slope of 1 when x is 0. And saying g of 0 is 1 tells me that 0, 1 is the point on the graph. The second thing we took from this, the slope of the graph is 0 at x equals -2. So it's a turning point there. So you can draw a little curve at x equals -2. Draw local max or min. I drew a local min in this case. The third bit of information, so that it has a vertical asymptote at x equals -5, which is on the left side of the domain. So draw an asymptote and draw it going up to positive infinity there. And then the last bit of information, this limit, told us that it's approaching 3 as you're approaching the right side of the domain. So you can draw a function, excuse me, a curve that's approaching 3. So what we took away from all this today is that the derivative is the same thing as the instantaneous rate of change of a function to a function a. And we can use the derivative with a lot of different applications and function types. So we'll be talking about the derivative again in the next section.